Hello, good morning, good afternoon, everyone. Okay, my name is Catherine Chan from Aruba Channel Service Team, the Partner Branded Support Program Managers in APJ. Thank you for joining the Technical Troubleshooting webinar today, which we are specially designed for Aruba Partner Branded Support Partners and also our Managed Service Partners. This is already the fourth webinar since September. We conduct this technical webinar for all our PBS and MSP partners every month since September. This is already the fourth webinar. Thank you so much for all your support. And every month we will have different topics that in particular to address the technical support knowledge for all our engineers. So I would also like to take this opportunities to just a kind reminder and to emphasize the importance of all our PBS certified engineers need to continually attend this monthly webinar to enhance and uplift your configuration and troubleshooting skill on our Aruba products. We will continue to offer many different kinds of the product knowledge that share with our specialist team to you on every month. So a kind reminder, attendance would be recorded and also tracked in your respective company dashboard performance report on a quarterly basis. So your attendance are definitely is very crucial and important well, to continue the success of your company under this PBS program. Thank you again for your support. Okay, come back to today, our webinar. As usual, very thankful to the Aruba Tech Support Team facilitating this monthly technical webinar. Actually, every time we have Bharat, but he's on leave today, and his team to organize the topics and invite different subject matter experts every time to share their knowledge and experience with us. And today, our speaker is Govind. He is from our engineering resolution team, along with Jovine. Jovine here today will also be our Q&A panelist. So while Gopin is presenting all the knowledge and all the slide with us, if you have, whenever you have questions, then you are always welcome to drop your question on this Q&A. Another thing is that, okay, Jovine will be our panelist, and we also have Gopin as a presenter. That actually is both of them are from our level 3 and level 4 support. So they definitely have a very wealth of knowledge that what you have been experienced in the field. So just make use of this time to get their insight throughout this session. Gobi, can you go to the housekeeping slide that before we start, I just want to share with you a few things in order to make it as more interactive. We will open our Q&A panel. Jovin will be here. And also we will try to mute all of you in order to avoid some of the distraction. And last but not the least, please stay throughout the whole session until it's finished, because we want to gather your feedback. There are a few very simple questions we'd like to ask for your feedback as well. So without further ado, I would like to pass the time to Gopi to start the presentation today. Thank you, Gopi.
All right, thank you, Catherine. Hi, this is Gopi. I hope you all are doing good. Today's session is about Tunnel Node in Aruba operating system. So this is the agenda for today. So I'll be providing you details on what is Tunnel Node, why we need Tunnel Node, and the concept of per port tunnel node and per user tunnel node, and how it is designed and the features of per user tunnel node. And also I'll be sharing you commands and the debugging that we normally use for normal issues. So let us move on to the topic. So what is tunnel node? So tunnel node is a feature that will redirect wide user traffic from the switch to the controller. So by redirecting the traffic, we are enforcing the client to reach the controller, and by this the features in controller like DPI, firewall policy, and other options offered by Aruba controller can be enforced on the client side. So this feature will work in standalone and also cluster controllers. So when as cluster is involved in this, so the scalability and the performance and the load balancing, it's all applied for this client that is falling in tunnel node. So uh, in a normal scenario, when a client connects to Aruba AP, there will be a tunnel formed to the controller, and AP will be forwarding the tunnel traffic to the controller. So here, this concept is like we are removing the access point and we are connecting a switch. So think like the switch is going to work like an AP. Okay, so clients connecting to the wired port on the switch, all the traffic will be tunneled to the controller. So that is the concept here. So by doing this, we are also hitting the colorless port uh, feature, which is uh, we can assign any VLAN to the port uh, without even configuring on the port itself. We can push the VLAN from the controller to that port. So let us move on to the topic why we need tunnel load. So as I mentioned, when the wired user connects to the network, all the traffic will be tunneled to the controller. So this is making the wired and the wireless network consistent. Okay, and because when the user connects to the wired network, they're going to feel the same way when they're connecting to wireless. The traffic will be handled in the same way how the wireless traffic is being handled. So that is the main use of tunnel node. So since all the traffic is reaching the controller in most of the scenario, we can also have a centralized policy management. We can push the policy from controller for the clients, or we can also have a clear path pushing the policy to the switch or the controller. So how does this tunneling works? So first, once the tunnel IP address is configured in the switch does a handshake with the mobility controller. So first it sends a bootstrap message to the controller about the version and the mode, whether it is going to be a per port tunnel or per user tunnel. So it will send a bootstrap message. It is called a switch bootstrap message to the controller, and the controller will do a response for that or acknowledgement for that. So once that is done, post handshake, the switch and the controller will establish a control channel using PAPI message. So this is on UDP 8211. As I mentioned, it's going to be the same as the AP that is working with the controller. So here the switch is forming a tunnel to the controller using GRE. Okay, so as we have the GRE header getting added from the switch to the controller, we need to have jumbo frames enabled in the network. From the switch to the controller throughout the network, we need to have jumbo frames enabled. Okay, so there are two types of tunnel. One is per port tunnel and per user tunnel. So here we can see about what is a per port tunnel node. So when uh, when the tunnel node is configured as a per port tunnel node, what happens is the switch encapsulate the packet from the host, that is a client that is connecting to the switch, and it will forward all the traffic to the controller in GRE. Okay, so then once the controller receives the packet, it will strip the GRE header and it will process the packet, and it will send the packet back to the controller with the GRE header, and the switch will receive that and it will strip it and it will process to the end client. So that is how the per port tunnel node works. So here, per port tunnel node, all the traffic that is coming in from that port will be tunneled to the controller directly. Okay, so the other traffic like BPDUs and LADP traffic are terminated locally on the switch. Okay, and in per port tunnel node, we need the client VLAN to be on the switch and also the controller. So once the client connects to the switch, uh, the traffic that is initiated from the client will be all the traffic will be sent to the controller inside the GRE tunnel. So that is per port tunnel node. So this is the configuration for per port tunnel node. So in switch, we need to configure the control IP as a tunnel node server, and the mode of that should be port based. Okay, so once this is done, uh, the switch will have a handshake with the controller and it will form the GRE tunnel. Now we need to tell the switch what are the ports that are tunnel node ports. Okay, what are the uh, ports that needs to be tunneled to the controller. So the command tunnel node server that we are using on the port will trigger a tunnel node for that port and the controller. So all the traffic that is coming into the port will be directly sent to the controller. So this is the configuration. So first tunnel node server and controller IP, and the mode is port based. Okay, and we can also set a backup controller IP. So in case if the primary goes down, the secondary will controller will the switch will establish connection with the secondary controller IP address. So that is also possible in per port tunnel node, but clustering is not possible in per port. Clustering is possible only in per user tunnel node. So when, as I mentioned, AP switch will be working exactly like the access point. You can also see the behavior is going to be the same. So switch will consume one AP license. Each switch will consume one AP license. And if we need to have a customized policy, you need to have a PIF license. If you need to change the policy or change the user role the user is for falling in, then you need to have a PIF license in the controller. But for this setup to work, we definitely need a AP license in the controller. For each switch, there should be one license in the controller. And this is a configuration, a sample configuration for per a port tunnel node. So on the left side, you can see the controller configuration, and the right, you can see the switch configuration. So I'm giving the tunnel node server IP address, the control IP address is 192.168.2.1. Once it is done, switch will automatically form a tunnel to the controller. And you can see the interface 6, 7, and 8. I'm adding that in tunnel node server list. So these ports are tunnel node ports now. Once this is done, all the traffic that is coming in through this port will be sent to the controller using the GRE tunnel. So once the traffic is received on the controller side, it will be falling in the wired AAA profile. So I have configured wired AAA profile as a sample profile here, where you can see the policies that are mapped. So all the traffic that is reaching from the switch to the controller in per port tunnel node, they'll be falling in wired AAA profile. Okay, so we don't have any control on that. So all the traffic will be falling in wired AAA profile. And in that wired AAA profile, you can have any other authentication for that. So it's normal, like for wireless, what is happening, you can trigger for the same traffic. So this is the frame contents that is happening during the tunneling. So you can see the client initiates the traffic and it reaches the tunnel configuration on the switch. That is the tunnel node. And you can see the GRE header is getting added and it reaches the controller. Controller will strip the GRE header and it will process the payload and it will respond back with the GRE header, and switch will decapsulate that packet and it will process it, and it'll be sent to the end host. So as I mentioned earlier, the authentication is by wired AAA profile. So for per port tunnel node, when the traffic reaches the controller, it will be as per the wired AAA profile configuration. So once that is done, as per the authentication configured in the AAA profile, you can also send a different role, that is a post auth role, or you can also send a different VLAN. So even if the client is connecting to VLAN 1 on the switch side, post authentication on the controller side, you can push a different VLAN to the controller. So that is what it's mentioned as like the VLAN can be overridden on the controller. So this is a per user tunnel node or user-based tunnel. So this is it's the same as per port tunnel node, but here we have a control on the traffic that needs to reach the controller, or we can route the traffic locally. Okay, so here we are doing authentication on the port level. So client is connecting to the switch, and on the switch, we are doing authentication whether this traffic needs to be sent to the controller or it should be bridged locally. So we have a control on that. Uh, so when the client connects to the port where we have per port tunnel node, there'll be a local authentication happening either on the switch side, or switch will be sending it to ClearPass or any other server for authentication. So like per port tunnel node, per user tunnel node will also need one license, one AP license for this to work. Okay. So as I mentioned, we can decide whether the traffic needs to be reaching the controller or we can reach the traffic locally. You can see the diagram here where we have client role A and role C. Okay, you can see we have a command tunnel redirect in role employee and role camera. So which means that users falling in these role are qualified to send the traffic to the controller. So user falling in this role, traffic will be sent to the controller directly. Okay, and you can see another role, local employee, where we don't have tunnel redirect configured. So which means that the traffic will be sent locally. You can see on the diagram, you can see C's traffic is not inside the GRE tunnel. It is just going to the local system. So the other traffic, you can see we have tunnel redirect configured, so it will be sent to the controller. So let us see more about how this user-based tunneling works. So first, the switch does a handshake with the mobility controller and establish a heartbeat with the controller. So once this is done, so this is a configuration. Once this configuration is done, automatically the switch will do a handshake and it will form a GRE tunnel with the controller. So you can see I have given the reserved VLAN as VLAN 1000, for example. Uh, this is it is not required that this VLAN should be on the switch side. It is just a temporary or a dummy VLAN. So whenever the traffic is reaching the controller, the VLAN will be with this value, like a dummy value. So once this is once the tunnel is established, GRA tunnel is established, you can see when a client connect to the switch port, then it can perform either a .NET authentication or a MAC authentication, and using a local server in the network, a ClearPass server in the network. And once the authentication is done, you can see in that configuration, we have given the command tunnel node server redirect. So which means that we are authenticating the client using the local server, and post that we have configured tunnel node server redirect in that initial role. So in this scenario, the client traffic will be sent to the controller. So you can see the user formed a tunnel with the mobility controller. Okay, so The main difference between per port tunnel and user-based tunnel is the command that we have here, tunnel node server redirect. So if this is not given, then the traffic will not go to the controller and it will be routed locally. And in tunnel node configuration, you can see the mode will be role based. So if you give mode as role based, that will trigger user based tunneling. So post authentication, the user will form a tunnel to the controller, and uh, all the traffic will be sent to the controller using the GRE. So once the traffic is received on the controller side, then we can enforce the policy and DPI. Okay, so in the same scenario, uh, we can have when the traffic from the switch reaches the controller, and if there is no secondary role configured, so you can see the secondary role here in the configuration. So this configuration is on the switch side. So after authentication, we are making the client to follow an initial role. In initial role, we have tunnel node server redirect, and the secondary role is a test role that we have given. So when the traffic reaches the controller, it will be in that secondary role. Okay. If there is no secondary role given, in the controller, we have a default role that is a tunnel node user. Clients will be automatically falling in that role in controller if there is no secondary role applied. So this is a flow chart for per user tunnel node. So when the user connects to the port, they will authenticate. They will get authenticated locally from the switch side, and if the authentication is passed, switch will apply a user role. In that user role, if we have a redirect configured, traffic will be redirected to the controller. And if there is no redirect ACL, a redirect command, then the traffic will be routed locally. So if we have a redirect configured, traffic will be reaching the controller. And you can see specify secondary role. If there is a role, controller will use that. If there is no role, controller will put the user in default tunnel user role, and it will apply on the policy will get applied as per the configuration in that role. So this is the flow of authentication and the traffic handling for per user tunnel node. So per user tunnel, per port tunnel node, it has just the backup controller configuration. So once the primary goes down, it will go to the backup. And it will not support clustering, but per user tunnel node, which is user-based tunneling, will support clustering. Okay. So you can see first the controller will establish heartbeat. First, the switch will establish heartbeat with the controller. So switch whatever IP address that we are giving as a control IP in tunnel node server configuration, switch will establish GRE to that controller first. Okay, even that controller is not the leader or the leader, it will establish tunnel node to that controller, whatever IP address that we're giving. So here we'll be giving the MD's IP address in clustering. Okay, so once the tunnel is formed, then controller will send the node list and the bucket map. Who is the secondary switch anchor controller? SAC here is switch anchor controller. S is secondary switch anchor controller, a standby switch anchor controller. Okay, so once the switch receives that information, uh, here we can take uh, like MC1 is the SAC. Okay, so first we are going to configure the IP address or as a tunnel node server. Then it will establish tunnel to that controller. That will be the leader, and that leader controller will tell us the information about the node list and the SAC, who is the secondary switch anchor controller. And once the switch receives the secondary switch anchor controller information, then switch again set up another tunnel to the secondary controller. Okay, so this is the same how the access point will work. So we are just using the making the switch to work like an access point. Okay, so after the switch forming a tunnel to the SAC, and when we are connecting a client to the switch port, it makes the .NX or MAC authentication or both in that switch port, and just the normal user based tunnel flow happens. So the user will get authenticated locally, and as per the role that is getting pushed, whether the user will traffic will be redirected to the SAC or sorry the UAC, or it will be routed locally. Okay. So this is the main configuration that is needed for user-based tunneling, tunnel node server redirect. Okay, if this command is not configured in the user role, all the traffic will be routed, will be sent bridged locally. So this command is configured, then switch in cluster scenario, switch will send a user heartbeat to the AAC, and it will get who is the what is the current bucket map, and it will get the bucket map, and it will process it will find who is the current UAC for the controller, user anchor controller, and it will send the traffic to the particular user anchor controller. You can see a 6, you can see switch is directly setting a user anchor controller tunnel to the user anchor controller here. So after getting connected to the switch port, we are finding we are getting authenticated, and we are going to the switch anchor controller, and we are getting the bucket map and other values, and we are finding who is the USE, and with that we are forming a tunnel to the user anchor controller. So this is a sample user table that is on the user anchor controller. You can see default tunnel node user. Okay, so yeah, you can see default tunnel node user, which means that there is no secondary role configured in switch. So that is why they are falling in default tunnel node user. And this is the primary controller, which is the user anchor controller. And you can see show user table standby. You can see there is another tunnel formed to the standby controller, and you can see what is the active USC IP address in that. You can see a dormant user is added to the standby user anchor controller. So there are scenarios where there will be a switch connected to a switch behind a switch scenario where uh, we don't have any configuration related to tunneling on the second switch they're connecting to the first switch. So in that scenario, uh, the traffic that is initiated from the non user based tunnel switch will also be authenticated locally, and it will be sent to the controller if there is any redirect configured on the user role. So maximum allowed on the port side is 32. And when the traffic is reached on the controller side, you can see the tunnel ID will be same 47 47. You can see the same tunnel if they are coming from the same switch port. So in tunnel node configuration, we can give controller IP plus the backup controller IP. So it is like giving LMS and backup LMS IP address for an access point. So here, when the switch keeps sending keep alive message to the primary, and also when there is a miss for 8 heartbeats with that current primary controller, then the switch will try to contact the backup controller. So when there is 8 heartbeat miss, then the switch will establish the tunnel. It will try to establish the heartbeat tunnel with the backup IP address that we configured as a control IP. So this configuration tunnel node server, control IP, and backup control IP, it is on the switch side. So we do have scenarios where we have VRRP configured between two controllers, and we are using the switch, the control IP address as the VRRP IP in tunnel node configuration, the switch side. So what happens is when the configuration is done with the VRRP IP as tunnel node server IP, switch will establish GRE tunnel with the current VRRP master. When the master fails, uh, this switch will have some missed heartbeat, and at that instance, when there is 8 heartbeat misses, then the switch will re-establish the tunnel with the same VIP IP, and it will tear down the current tunnel. It will establish the tunnel once again because the previous master is down. So we have a new master. So at that time, it will establish a new connection. So these are the main difference between per port tunnel node and per user tunnel node. So per port tunnel node will have all the traffic tunneled to the controller. So we don't have any control on the traffic. The port configured as tunnel node port. When the user connects to that port, all the traffic will be sent to the controller. But in the per port tunnel node, we can have a control on whether this client traffic should be reaching the controller or it should be bridged locally. So that is a main difference. And second, the authentication for per port tunnel node will be done on the controller side, and the role assignment is also on the controller side. But on the per user tunnel or port-based tunnel, you can see the authentication is done on the switch side, and the role can be also put on the switch side. And on the per port tunnel, the default the default configuration is triple authentication wide, and on the per user tunnel, it'll be default tunneled user if there is no role mentioned in the switch side. So I'll share a few commands that we use to check the state of issue. Um, the command show tunnel node manage status. It will show whether there is any issue with the licensing. So you can see if this is on the controller side, and you can see if there is no license available for this setup to come up, the AP license, you can see the message unbootstrap request failed and not received. Okay, and you can use the command show license, show AP license usage, uh, and in that you can see active per user tunnel node. So you can see it's mentioned as one, which means that we are using one switch in the network with the tunnel node configuration. And show tunnel node server state. This command will show the current status of the tunnel node, whether it is registering or complete. Okay, so here in this scenario, the state is registering. So that is why we see the MAC address as 0. So once the registration is done, so registering is like the handshake that I mentioned. So once the handshake is done, the state will be complete and the MAC address of the switch will be mentioned here. So this command show tunnel node server state is on the controller side. Okay, this is port-based uh, tunnel debugging. So these are the commands that we use to check the status and the heartbeat messages between the switch and the controller. So the command edo mst mts set. So you can see these are the command, and debug destination session is like we are printing the output in this particular session. Okay, and once this is done, so you can see uh, for port based tunneling, when the port is added as a tunnel port, you can see tunnel port added. Okay, and also you can see switch will stop learning MAC address on that particular port. So these are the logs that will get printed for debug that we enabled. So here, when the port is removed from the tunnel node, you can see an unbootstrap message sent. So switch will send an unbootstrap message to controller, and also it will mark the port as down. So that is what we are seeing here in log. So if a client is getting connected, and if they are not performing any tunneling operation, then we can use this command to confirm whether the flow of the pattern is followed, whether the port is first added and then the MAC address is learning is stopped, or we can just try to bounce it and we can see whether there is any unbootstrap request going on. So this is for user based tunneling. So this is a command. I I missed to mention. So no debug destination session. So this is a command to stop the debugging so that we enable. So once we enable the above the first two commands, you can see you'll see the logs that are getting printed about the tunnel node port that is getting added, or if it is getting removed, the status of bootstrap and the unbootstrap messages. Okay, so debug user TN, user based tunneling. So you can see it's a different user bootstrap that is sent. You can see a bootstrap request sent for the user from the switch. And once the tunnel is successfully created, you'll see a message, a creation of multicast tunnel to controller. And this is for the user. Okay. And if you enable a port with a user based tunnel, uh, we can see these messages getting printed, the bootstrap message to the controller IP, and the user bootstrap message from the switch to the controller. So this is the part of the first message that I showed. So this is a sample message about like how the bootstrap message for a switch will appear in the logs when the switch tries to contact the controller. So this is on the controller side. This is captured on the controller side. You can see there is a bootstrap request from the switch, and there is a bootstrap acknowledgement to the switch. And you can see the same happens for SAC, um, standby switch anchor controller, and you can see the bootstrap request and bootstrap acknowledgement. So whenever there is any issues for the switch to form a tunnel, you can use this command of the controller to confirm whether the request is hitting the controller and we are sending a response. And in user-based tunnel, there'll be a user bootstrap. But in PPTN, you can see there'll be only the switch bootstrap, right? But here there'll be a separate bootstrap for the user. So when the user connects to um, a, a tunnel node, here we need to find the active UAC and the standby UAC, so that there'll be a separate tunnel formed from the switch to the controller. So to know that, there will be a separate bootstrap, a user bootstrap from the switch to the controller. So this log is taken from the controller where you're seeing there is a request from the switch with the client information about what is the current client VLAN and what is the role that is currently mapped. Okay, and also there will be a response about in that log about who is the SUAC for the client. And when a client is reaching the controller in role A and on VLAN A, we can make the client to fall in a different role and different VLAN. So you can see we are sending a VLAN. The VLAN 1001, it could be a dummy VLAN that we configured as a reserved VLAN, and it is reaching the controller, and you can see that there is another VLAN assigned to that particular user. Okay, so this will take effect. So this will override the existing VLAN configuration. So command show tunnel node manager tunnel nodes. You can see who is the active switch anchor controller and who is the standby switch anchor controller. And the flag will be mentioned as A for active switch anchor controller. So Uh, so this by this command, you can see who is the active switch anchor and the standby switch anchor. So with the same command, you can see the tunnel nodes, whether uh, for that particular client, whether this is the active controller or it is a standby active controller, standby user anchor controller or active user anchor controller. So you can use the same command to check who is the current UAC and SUAC for the client. And also we can check who is the SAC, which is switch anchor controller and standby switch anchor controller. So if we need to confirm whether there is any traffic going between the controller and the switch, whether the status of the tunnel is fine, we can use the command show data path session table. So that will give us the in caps and D caps value. We can see whether that is getting increased. Okay, so you can see the port number and the MTU size, the current MTU size, and the D caps and in caps value. Okay, and you can see 47 is GRE. So you can see the values that is getting increased if there is any activity inside the tunnel. Show data path station is the command that we use to check whether the particular user is a tunnel node user. You can see the flag U that is mentioned for show data path station, which means that particular user is a tunnel node user. So these are the supported products for tunnel node. So for controller, we can use 7200 series or 7000 series. For switch, 2930, 3810, or 5400R. So these are the switch model that we can use for tunneling, user-based tunneling or port-based tunneling. So we know what are the devices that are supported for tunneling, and now we are seeing what are the maximum tunnels that can be created on the controller level. So the max is for 7280 controller. And also the same is given for the switch. Catherine, we are done with the session.
Oops. Okay. Oh, hello. Hey, thank you, Gopin. Since we still have like 30 minutes, then shall we open the floor for any Q&A? Any questions that you would like to have? So I see there's a question, Gopin, in a Q&A. It's Aruba 9000 series from Chin Ko Hong. Hello, Ko
Yeah.
Hong. thank you for your questions. So I am currently allow you to, I will unmute you.
Okay.
Okay, see if you need any clarification from Ko-Hong, or can you answer with,
Yeah, so I need to confirm about this particular series. So I can answer this offline.
sorry?
I need to confirm whether this particular model of switch supports the controller supports. Yeah.
Okay. So Ko-Hong, do you have further questions, or you want to follow up right now with Gopi? I'm trying to unmute. Ask to unmute. Cannot. Okay.
Yes, the same can be implemented with SD-WAN. Yeah, we have one more question about implementing it on this cloud. So yeah, the switches and the branch gateways that are managed by SD-WAN can also use tunnel node. So instead of controller, all the traffic that is sent on that is triggered on the switch side will be sent to the branch gateway in a cloud solution.
Okay, thank you. So if you have any questions, that feel free to raise up your hand, and I will try to unmute your line. There is a follow-up question from Taurus.
Yes, per port tunnel node and per user tunnel node, they are supported in SD-WAN solution. Yeah.
So Taurus also asked any presentation file that using the CX switch. Do we have that relevant supporting document that we can share?
No, I don't have that handy, but yeah, I can do more research on that, and we can provide that.
Okay, I will follow up with you then.
Okay.
Any other questions? I will give another 2 to 3 more minutes for you to give some, gather your feedback, and also take some reflection if any questions you have. Maybe we wait for 2 to 3 minutes to see any more questions from the floor.
Yeah, we have one more question. So
Yeah, from Gao Hong. Yeah.
yeah, this particular model, I just need to confirm about support for PUTN 6000 series. Yeah, because I'm sure that it'll support for 7000 series and the current 8.x architecture, and also SD-WAN solution is applied. So I'll confirm for this CX 6000 series. So I guess it's the same question as the first one. Yeah.
So we'll confirm to you later on.
Yeah.
Yeah. Any other questions on the floor? Well, in the meantime, I'm going to launch the survey. So please give your feedback to us. There's only a very short questions for 3. Okay, I will launch it right now. While you are finishing your survey, you can stay on the line to ask any sort of question you have in mind. So Kobin, do you have any things that you want to supplement of what you just present, or any further things you want to enhance of your thoughts in this presentation?
No, Catherine. No.
Okay,
So
all right.
this is the same working behavior as access point. So we're just replacing the access point with a switch. So most of the working behavior is same how the access point is going to work with our Aruba controller.
Okay. So for those that okay, I think on the sharing from Coping, that's about the contents that we would like to share the insights with all of you. So the training material and also the training video we will upload to the partner portal, and I will also send through the email to all of the participants today, later today or by tomorrow. If you have no further questions, then we can just close the call today. And stay tuned. Our next session will be held in January, probably in the mid in January. And we will, as usual, send the same invite and registration to all of you later this month. So Corbin, how about we stay in the line for 5 to 10 minutes, since it's still we have 30 hours from this session. So shall we stay in 10 minutes to see if any further questions that the participant have?
Sure.
Thank you. For those attendees, if you have no further questions, feel free to off the call, and we will just be open in 10 more minutes. We'll stay here in 10 more minutes to see if any further questions the floor may have to cope in. Thank you very much for your time today. Okay, Gopin, since there is no more questions from the floor, then we will close the call today.
Okay, Catherine. Thank you.
Thank you, Gopin. Thank you, Jovin. Thank you. Thank you all. Bye-bye.
Thank you, everyone.
Bye.